Alright, ladies and gentlemen, in today's lesson, what we're going to be discussing is going to be how we divide with complex numbers. Now, complex numbers, their operations, everything that we've been doing with them are very similarly related to doing operations with radical numbers. And depending on how well you recall those operations from prior math classes, may help you in understanding what we're doing here. But if you don't remember them, it's not the end of the world. We're going to show you how to do it. Now, the key thing is that an imaginary number cannot be in the denominator of a fraction, kind of like a radical number can't be, an irrational number cannot be in the denominator of a fraction. So in order to eliminate an imaginary number from the denominator of a fraction, we're going to kind of look at this step right here. We're going to take whatever the imaginary number is, take the conjugate, and then multiply the conjugate to the numerator and the denominator and simplify it from there and see what we get. Okay? And this part right here is almost repeating itself as far as saying what what the previous screen said, but can't have an imaginary number in the denominator, and if so, multiply with the conjugate and simplify it. So let's take a look at this first example. Negative 3 divided by the square root of negative 64. Now this example is relatively simple in the fact that they're giving us a perfect square number of 64 with which to work. It's not always going to be a perfect square number, but because it is, it'll just make it slightly easier when working this particular one out. Now in the numerator, there's nothing to really do. In the denominator, it simplifies to be 8i when I take the square root of negative 64. Now some of you may be wondering at this point, well, shouldn't the square root of negative 64 really be a positive 8 and a negative 8i? And the answer is yes, it really should be. Now, it won't have an effect if I use a positive 8i or a negative 8i on the absolute value of the answer when it's simplified. It will have a difference on the sign. But for the purposes of these examples and the questions I'm going to ask you to do in class, we're going to just limit the answers when I simplify a radical number to the principal value, which would be the positive answer. So that's why I'm going to leave it as the 8i rather than a negative 8i. Now the conjugate of the imaginary number in the denominator is simply a negative 8i. And what the examples or what the instructions told us to do on the previous screen was saying, okay, we'll take the conjugate and multiply it to the numerator and the denominator and then simplify it, see what you get. So in the numerator, we have negative 3 times negative 8i, which would give you a positive 24i. In the denominator, positive 8i times negative 8i would give you a negative 64i squared. In the numerator, nothing is really going on, but in the denominator, the I squared is really just negative 1. So the negative 64 times negative 1 is really just 64. Oops, and I forgot my I in the numerator. Now at this point, the 24 and the 64 do have a common factor of 8. So the 24 over 64 will simplify to be 3i over 8 to make sure that it's in its most simplified form. This answer here of 24 over 64 is not incorrect, but it's not completely correct because it's not simplified all the way. Next example, we're stepping it up just a little bit with the addition of a real component in the denominator along with the imaginary component. So let's go ahead and simplify the denominator. The 3 minus the square root of negative 25 would be 3 minus 5i. And just like in the previous example, because we have the imaginary number in the denominator, we must multiply by the conjugate to eliminate it and create a positive number in the denominator. So the conjugate of 3 minus 5i is simply 3 plus 5i, and I'm going to multiply it to both the top and the bottom of the fraction. Now, in some cases, it may be beneficial for students to put parentheses around the things that they're multiplying to clearly show that that's exactly what we're doing. It's not necessary, but sometimes it's beneficial. So here we have in the numerator 7 times the 3, which would be 21. the 7 times the 5i, which would give me a positive 35i. And in the denominator, we're multiplying conjugate pairs together. So I'm not going to FOIL those out here. I'm going to just use this rule. When we multiplied conjugate pairs together, a squared plus b squared. Well, a is 3, so 3 squared would be 9. B is a 5, 5 squared would be 25. Now in the numerator, they're not like terms. 21 plus 35i don't simplify at all. And in the denominator, 9 plus 25 would give me 34. Now here, the 21 has a denominator of 34, but they don't have any common factors, so it doesn't simplify. And 35 over 34 also doesn't have any common factors, so it doesn't simplify any further. So right here is the most simplified that we can have this particular expression written. Moving on, again, this is very similar to the first problem, except in the denominator, they've already kind of simplified the radical number for us. And in the numerator, we have not just a real number, but we have a completely complex number. So the conjugate of the denominator in this case would be negative 4i. And again, if you want to, just kind of put things in parentheses to show how and what is being multiplied. It's not completely necessary, but it's beneficial for some students to see it that way. So the negative 4i gets multiplied to that 2, which would give me a negative 8i. The negative 4i gets multiplied to the negative 5i, which would give me a positive 20i squared. And in the denominator, 4i times negative 4i will give me negative 16i squared. So we have a couple I squared terms which are really just negative 1. So 20 times negative 1 would give me a negative 20, and negative 16 times negative 1 in the denominator would give me a positive 16. Now, because it does say write it in a plus bi form, where a is the real number, we're going to go ahead and just rearrange the order of the numerator. Negative 20 minus 8i over 16. And further, I'm going to just go ahead and break it up. Again, it's not necessary, but for those of us that need to see, this is why we're going to simplify it the way we do. The negative 20 has a denominator of 16, just like the negative 8 does. We write it over a single denominator just because it's slightly more efficient, but it can be confusing when it's time to simplify things. The negative 20 over 16, both of those simplify with a common factor of 4, so that would give me negative 5 over 4. But the 8 over 16 has a larger common factor of 8, so here this would be 1/2 I. So we do need to kind of pay attention to what are the values of the numerator when we simplify it with the value of the denominator to make sure that, because sometimes when we simplify it, they don't always have the same denominator. Now here, this is the last example that we're going to take a look at, and probably is the most complicated example that we have for these types of problems, simply because the numerator and the denominator both are written in complex form. There's no just real numbers or just imaginary numbers. But the process of what we do doesn't change. Because we have an imaginary number with negative 2i in the denominator, we have to multiply by its conjugate to eliminate it from the denominator and leave just a number behind in its place. So the conjugate of 3 minus 2i is 3 plus 2i, and I'm going to multiply that to both the top and the bottom. And again, really just because I think it might help some people that are watching this, I'm going to put everything in the parentheses to show this is how we're multiplying it. And it makes it a little more clear, especially for some of us, that we're foiling both the terms in the top and both of the terms in the bottom. So let's see what we get. The negative 9 times a positive 3 will be negative 27. Negative 9 times a positive 2i will give me a negative 18i. Here, the 6i times 3 will give me another 18i, but this one's positive. And the 6i times the 2i will give me a positive 12i squared. Now in the denominator, similar to the example that we saw a couple of problems ago, because we're multiplying with conjugate pairs, I'm not going to bother foiling them. I'm going to just look at the rule a squared plus b squared, where a is a 3, so 3 squared is 9, b is the 2, 2 squared is 4, okay? And now I'm going to start taking a look at the numerator and see what can we simplify. Now in the numerator, because we FOILed, the two terms in the middle are always going to be like terms, so they always have to combine. But in this case, it worked out very nicely because negative 18 and a positive 18i are opposites, and they cancel each other out. And the I squared attached to the 12 also simplifies to be a negative 1. So negative 27, the positive 12i squared simplifies to be negative 12. And in the denominator, they're like terms already, so 9 plus 4 gives you 13. And just keep going in the numerator, 27 negative minus 12 will give you negative 39 over 13, which simplifies very nicely to a single whole number. Well, not a whole number, but a single integer, negative 3. And that's pretty much it as far as what it takes to, what we have to do when we're dividing with a complex number. We just identify what the conjugate is and multiply whatever that conjugate is to the numerator and the denominator of your fraction. And that's about it. So anybody, if you have questions, please make sure you come in for some tutoring, and we'll see you in class soon. Thanks.